couldn't touch the screen on ours. We had to get a projector.
All right. Now today we're going to be working more with graphing quadratic functions. So before when we were graphing them, we had a table already made for you. You just plug in those values and graph the point from there. Here you're going to be learning a method where you can do it by yourself without needing a table. Well, it's kind of like having a table. All right, so we're actually going to skip that first part here. So to the function when it is written in standard form, what is the standard form for a quadratic function? Right,
Is that f of x equals ax squared plus bx plus c?
Yep,
Yeah.
that is the standard form. Y equals ax squared plus bx plus c. So then, now we can go back to the first part. It says the y-intercept of a quadratic function is always going to be a certain value. So what's the y-intercept of any function? What's the y-intercept? Isaiah? Yeah, so it's any point on our graph where it crosses the y-axis. So what is the x value for any y-intercept going to be then? Kayla? 0, exactly. So for any y-intercept, x is always going to be 0. It can be any point on there. So if we plug in 0 for in our standard form here, what do you think we're going to end up with?
0.
No. Morgan? Whatever number c is. So our y-intercept for any quadratic is going to be our c value. Alright. Now we're going to be using like 5 things to graph our quadratic functions. The first one, we're going to use our axis of symmetry. So everyone knows that the axis of symmetry splits the parabola in half, 2 symmetric halves, so what's ever on one side, if we flip it over, everything should be the same on the other side. We can also use the vertex. All right, then last two, we can use our y-intercept. So we use our y-intercept, and we can also use symmetry. So what I mean by symmetry is that if we have one point on one side of our parabola, since both halves are symmetrical, we should be able to just flip it and find the other value that would be on the other side of our axis of symmetry. So when we're graphing in our notes and on your assignment, we are going to have at least 5 points on our graph. When your graph, if you have less than 5, it's not going to cut it. All right, then. Moving right along. This first one, y equals x squared minus 6x plus 9. First thing we should always find is an a, b, and c value. So Morgan, what's our a value for this one? A is 1. Brooke, what's our b value? -6. And then Riley, what's our c value?
9.
That'd be positive 9. So the first thing we can pretty easily find is our y-intercept. So our y-intercept is always going to be our c value. In this case, it's 9. So 1 point on our graph is going to be what order pair? Riley?
0, 9.
0, 9.
Yay.
That's our y-intercept, so that x is 0. Y is going to be 9. So everyone on your graph down here, plot that point on it, 0, 9. Just got 1 point there. All right.
Would that be the maximum?
Nope. That was just the y-intercept. So sometimes it might be,
Sometimes it would be minimum.
sometimes it might be the minimum, sometimes it might be the maximum, but we don't know that yet. So we have to keep finding points in order to do that. All right, now, next thing we do, we find our axis of symmetry. And who remembers the formula that gets us there? Sam? So x equals negative b over 2a. That's right. So when we plug in our a and b value, what we get out of it, that should be our axis of symmetry, so we can substitute. B is, there we go. Negative 6 goes upstairs, 2 times 1 goes downstairs. All right, then, after we finish doing all our math, what should we be left with, Ricky?
3.
So 6 over 2, because we simplify it out, so this goes to x equals 3.
Yay.
All right, so we just found our axis of symmetry, right? All right, so let's put that on our graph too. We can just make that a dashed line. So x equals 3.
With your ruler.
And that's why I handed those out. All right, so do you guys remember yesterday or the day before? I think it was, yeah, it was yesterday. Once we found our x value, or our line of symmetry, we got an x value, so we can now use that to find the y value of our vertex, right? So if we have our original function y equals x squared minus 6x plus 9. Whatever x value we found over here, we just plug that in for x over here. So did everyone get y equals 0? And if you didn't, you might want to check the work because it should be 0.
Alright.
All right, so we got an x value and a y value. So our order pair for our vertex should be what? 3, 0. That's our vertex. So if you look up here, our y-intercept, that was our first point. The vertex that we found right now, this is our second point. So if we go down to our graph there, set our vertex is 3, 0, so we go over 3, it's going to be right there. All right, so found 2 points so far. We found our y-intercept and our vertex. Now the last point that we need to find without using symmetry, we'll do that later. We can pick an x value between our y-intercept and our vertex to determine the y value of our third point that we're going to find. far we have 2 points, our y-intercept and our vertex, right? So what's the x value of the y-intercept?
0.
0. What's the y value or x value of our vertex?
3.
3. So we've used 0 and we've used 3. So what are numbers that are in between 0 and 3?
1, 2, and
1 and 2 are the simplest ones, right? So we can pick either one. Which one do you guys want to use?
1.
All right, let's do 1.
Yay.
So when x equals 1, I'm going to put that in there. We have our function y equals x squared minus 6x plus 9. We just substituted in for x. Yes, I do. Y equals 4, so 1 minus 6 is negative 5. Negative 5 plus 9 equals 4, that's right. So the order pair for this point here should be what? Riley? 1, 4. This is the third point we found. So we can go right over to our graph, 1, 4, that's right there. Alright, so far we've found 3 points. These last 2 points that we're going to find, we're going to use symmetry to find them. So, symmetry means that whatever's on one side, if you flip it over, like our axis of symmetry, everything should be the same on the other side. So, let's check our y-intercept. How many units away from our axis of symmetry is that? 3 units, right? We have 1, 2, 3. So if we flip that over onto the other side of our axis of symmetry, how many units do you think another point should be? 3. So we go 1, 2, 3. And what point is that? Six, 9, yep.
Do we have the order pair by it?
Yes, you do. The points that we're finding using symmetry on your graph, I want you to label what the point is. What is it? All right, so we did that one. We have 4 points so far. We need 1 more. We can use that third point that we found, 1, 4. We can use symmetry to find that one. So, Morgan, do you want to give us the answer? 5, 4. So 1, 2, 3, 4, 5, 4. This is 2 units away from our axis of symmetry. If we go the other way, it should also be 2 units away, and yes, it is. Now, how many points do we have? 5. So now all we have to do is just graph our function. And I forgot one thing. What ordered pair is this point? The last point we found? 5, 4, so you have to put that on your graph also. There you go.
It could be a B, wouldn't it?
Yes, Isaiah?
We don't put our, we don't want it to be during reviewing our samples, we would not.
So if you don't label the points you found using symmetry, yes, that would be incomplete. All right. Anyone have any questions so far? All right then. We can move right along to the back side. So So first things we find is our A, B, and C value. Lane, what's our A value for this one? -2. Ian, what's our B value?
6.
6. And Christina, what's C?
2.
2. That's right. Alright, so first point we can find usually pretty easily is our y-intercept. So what would it be? Say that again, Michaela. 2, the y-intercept's 2, so ordered pair, 0, 2. First. Alright, so we found our first point. You guys go and plot that on your graph down there. Now the next thing we find is our axis of symmetry. Formula is -b over 2a. Yes, Christian?
-6 over 2 times -2.
Alright, so x equals -6 over 2 times -2. Alright. Then, once we simplify everything out, what should we be left with? -6 over -4.
Wait.
Yes, Ricky?
Couldn't that be simplified to negative or 3 over 2?
It sure could. So x equals 3 over 2. Another way we could write that. 1.5, and what's one more? 1.5. Any of those would be fine. Alright, we got our axis of symmetry, so now we put that on our graph. Where's 1.5 on here? Riley?
Right in between 1 and 2.
Right in between 1 and 2. So 1, there's 2, go right in between it.
Or you could relabel it as like.
No, no. Another class tried doing that. I want you guys to work. So what's the equation for this axis of symmetry again?
Negative 2x squared plus 6x plus 2.
Say what? No, for the axis of symmetry. X equals 1.5 or 3 over 2 or 1 and 1/2. All right then. There we go. Okay, so now we found our axis of symmetry. We found our x value for our vertex because it's the same thing as our axis of symmetry. So y equals -2x squared plus 6x plus 2. So what are we going to plug in for x here? 1.5. Anyone know what 1.5 squared is? That's 1.5 plus 1.5.
2.25.
2.25.
Yes, my
Then 6 times 1.5.
3. 9.0.
It's 9. You're thinking of 6 times 1.5.
Yeah.
Yeah. Alright, then. -2 times 2.25. negative 4.5 plus 11. So when we are all done, what should y be equal to? 6.5. Wonderful. So the ordered pair for our vertex should be 1.5, 6.5, right? And that is our second point. So when we have our second point, we go to our graph. 1.5, that's on our axis of symmetry. We go up to 6.5, 2, 4, 6.5. It's right there. And make it a little bigger.
In the center of the square. Right?
Yeah. All right, now. You have 2 points, and you guys, this would be the time when you pick an x value that's between our y-intercept and our vertex. So what's the x value of our y-intercept?
0.
0. Christian, what's the x value of our x, or our vertex?
1.5.
1.5. So what is the number between 0 and 1.5? 1. So when x equals 1. Now you just plug 1 into the function. So the function y equals negative 2x squared plus 6x plus 2. All right. I think you guys can do the rest here.
Whoa, those 2 points are really close to each other.
Blaine, what should our final answer be for this one? Y equals 6. So the ordered pair for our third point can be what are they? 1, 6, third point. All right. So our third point, 1, 6, go 1, 6, right there. All right, so we found our 3 points, we found our y-intercept, our vertex, and we found 1 more point. Last thing to do, now we use symmetry, use our axis of symmetry to reflect everything that we already have onto the other side. So let us start with our y-intercept. How many units away is our y-intercept from the axis of symmetry? It's 1.5 units away from it. So we have 1.5. So if we started our axis of symmetry, how far away do you think the other point has to be from it? 1 and then 1.5. So we go 1/2, 1. It's right there. So what point is that?
2, 3, 2.
3, 2. There it is. So that's 3, 2. Then we have our third point we found, 1, 6. How far away is that from the axis of symmetry, Ricky?
It's 2, 6.
Oh, I just had the point.
Like 0.16 is 1/2 unit away from our axis of symmetry. So how far do you think it's the point is going to be far? Yeah. It's going to be 1/2 away from the axis of symmetry. So what point is it going to be on?
2, 6.
2, 6. so this is 0.26. How many points do we have here? 5, so we should be good. Now the last thing we gotta do is draw our graph.
These are more complicated than yesterday.
Alright, so, yes, I did.
Do we need to extend arrows?
Yeah. Yes, you do.
Oh, all the way through the graph?
Yep, because quadratics go on forever, right? Because x equals like 20 isn't on that graph, right? But I can plug in 20 your function and get an answer out. Right, so that's why we extend. Alright. A couple things I want to mention. These are the 2 points that we found using everything else on our notes. Then we use the symmetry to find our other points. So what is the same about the point we started with and the point that we use symmetry to find? There's something they have in common. Isaiah, they both have the same y value, right? So like this one, this was 0, 2. We reflected it. We found 0.32. They have the same y value, right? Same with that one there. It was 1, 6. We reflected it to 2, 6. So when you're using symmetry, what should always be the same? Y value. All right. Now here's one more little tidbit. What if we had an axis of symmetry that was on 1/2? So imagine that, it's on 1/2. Then our y intercept, our x value is 0. We reflect that, find another point, so we have 0 and 1.
Yeah.
With vertex that would be 1/2, and with y-intercept that would be 0. So when we find our third point, we find values between our y-intercept and our vertex, right? So are there any good whole numbers that we can plug in? So when that happens, if there aren't any good numbers that you can just plug in that are between our y-intercept, then you would just have to extend the other way. So instead of going in between them, you could go to the other side. So like here, we use 1. We could have just as easily used -1 or -2. So, anyone got any questions? Yes, I do.
When it's, you said that you would like -1 or 2, when you go to the negative side, is there like a limit to
Well, I would say whatever value you pick, as long as it fits on the graph, you'll be fine. Like if you pick, like say -5 and you get -27 for your y value, that would work. It's not on our graph.